Now we are going to look at the other types of motion we come across in our day-to-day life. So we have already seen something about the linear motion, which is translatory, of course, a part of translatory. But other than the linear motion, you can also come across different motions like other types of motions. The first thing is, whenever a body motion is along straight line, this is called as a straight line motion or motion along a straight line. The other one is circular motion. So circular motion is the motion which moves about a fixed point. So the motion with reference to a fixed point. So taking this as the origin, if a particle moves along this circular path, then you say that it's a circular motion. So this is a circular motion. So in this case, how much time it will take to complete one revolution is called as time period. Time period. Time period is nothing but time period, or you can also call this as periodic time. Periodic time. So this can be defined as the time taken to complete one revolution. Time taken to complete one revolution is called periodic time. So here, if at all it is moving on a circular path with radius r, then time can be given as total distance travelled by it, that is given as 2 pi r. So time period is nothing but distance by its angular velocity, because it is moving along a circular path. That comes out to be 2 pi by 2 pi r is the distance by velocity. 2 pi by distance by velocity, that gives rise to be this one. So 2 pi r by v. If at all it is moving along a circular path of radius r with a velocity v, then 2 pi r by v is coming out to be the time period. So this is how you can calculate the time taken to complete one revolution. The third type of motion you have is oscillatory motion, and this is the to and fro motion about a mean point, about a fixed point. Example you can take as pendulum of a clock. Pendulum of a clock. So to complete one oscillation, we call it as the periodic time. So here this is the moon. Example here you can take example revolution of moon. Around earth. This is the example of circular motion. So these are the other types of motions we have, which is out of scope for us. So we will just look at only the linear motion to the greater extent. Yeah, coming to the explanation part. So we have already gone through the motion in a straight line so far, and we have applied the various equations of motion in determining the velocities, accelerations, etc., etc. And exclusively we have seen when a body is moving along x-axis, that means horizontally as well as vertically. When a body is moving horizontally on the surface, we are taking acceleration as a. when a body is moving vertically onto the ground, we have taken acceleration as a when it is moving towards the ground, and away from the ground we have taken as minus g. Unlike these, there are also other types of motions. One of them is circular motion. Circular motion means it is repeated. The path is repeated at regular intervals of time. That means when a body is starting over here, it is revolving around a circular path with reference to a fixed point. In that case, every time it has to come to the same point during its motion. Such type of motions, if the path is repeated, then you call them as the periodic motion. So circular motion is a periodic motion. So to complete this one revolution, whatever the time it takes, that is called as the time period. So the time period can be taken as time taken to complete one revolution. So as an example, Earth is revolving around the sun. So how much time it is taking? 365 days. So that is a periodic time of Earth around the sun. Likewise, moon is revolving around the earth. This is also a periodic motion, a circular motion. So, in order to calculate the time in such cases, time taken to complete one revolution, will be taking how much distance it is covering along the perimeter, that means along the circular path, that you divide with what velocity it is moving. Therefore, 2 pi r by the velocity giving rise to the time period. And apart from this, there is also another types of motions called as oscillatory motion. Oscillatory motion is nothing but a to and fro motion, just like a swing, cradle, tuning fork. Such devices make the motion which are coming under the oscillatory motion. So, to and fro motion about a fixed point, like your cradle or swing, whatever it is. So, pendulum of the clock is one of the examples of oscillatory motions. About these motions you are looking at in higher classes. So, up to now we will be keen about the motion along a straight line. So, these are something about the concepts of motion.